Welcome back, everyone. In this video, we're continuing 4.1. We're going to look at converting degrees to radians, and then we're going to look at converting radians to degrees, and then I've got an application question for you. So here, a side note, what you want to do is you want to keep what you want on the top. And what I'm talking about there is I'm talking about this ratio. So here, if I want radians as in my answer, then I'm going to have my ratio set up where I've got pi on the top because pi is referring to the radians, and then keep the 180 degrees on the bottom because it's referring to the degrees. Now for the other way around, if I'm wanting to result with degrees in my answer, then I'm going to have the 180 degrees on top and the pi on the bottom. Okay, so let's do a couple of these examples. So I want to convert 30 degrees into radians. So I take my ratio and I multiply 30 degrees by it. Okay, so then all I need to do is reduce this fraction that I get, 30 over 180 degrees. So take a 30 out and I end up with pi by 6. So pi over 6 is my answer for this first one. Now for the second one, I want 225 degrees and I want to convert it to radians. So I got pi over, 180 degrees. Ugh, can't write. And then that is going to reduce to, if I take a 5 out of here and a 5 out of here, I'm going to end up with 45 pi over 36, and I could still reduce that. Take a 9 out of here, I end up with 5. Take a 9 out of here, I end up with 4. So that's going to give me 5 pi over 4. All right, so why don't you give this one a try, and we'll cover it in class. Converting radians to degrees. So note when there isn't a degree mark on the number, so you see here there's no degrees, that means it's already in radians. Okay, so here we want to convert it to degrees. This is the ratio I'm going to use, and I'm going to take my 2 pi by 3 and multiply it with that. So you've got a pi in the numerator here and a pi in the denominator. That reduces, and you want to reduce out this 3 with this 180, and you end up with 60 here, and so then we've got 2 times 60, which gives us 120, and that ends up in degrees. So for this 1.6, now 1.6, it's not really too friendly to reduce out without using a calculator. So for this one, you're going to have to just multiply the 1.6 times the 180, and then you end up with 288 over pi, and you could also write that as a decimal. So this would be exact form, and this would be in approximate form, so an approximate decimal number. Okay, I'm going to leave this one for you to try on your own. Let's continue to the question on the next page, which is an application problem. So here we've got a central angle and the relationship between the length of the arc and the radius of the circle. So this is the relationship. So let's have a look at what this actually, so here is a circle, and then you've got the central angle, so an angle that is in the center here. This would be the arc length. You'll also see some textbooks use A, so you're going to see A equals theta times R, depending on what book you're reading at the moment, or what website you're looking at for some extra resources. So right here, I'm going to call it S. It's also referred to as arc length. Arc, it might make a little more sense to write arc there, but our textbook uses S, so I'm going to use S. And radius. Radius is R, so that's right here or right here, that line. One thing you have to keep in mind that's really important is this angle that's here is in radians, or it must be in radians. If you're putting it into the equation, you have to use the angle in radians. If you are solving for theta using this formula, it's going to give you the answer in radians. So something to keep in mind. All right, now a bicycle tire has a radius of 0.5 meters and travels a distance of 1.5 meters. Determine the rotated angle in degrees. So that's this angle right here that we're talking about. These are all the things that we know. We know that the radius is 0.5 meters. We know that the arc is 1.5 meters. And we also, we also know that we don't have any number for angle, so that's what we're trying to figure out. So we have to remember, since this formula, S equals theta r, you'll also hear some people refer to it as SOR, because this looks like an O. It only works for radians. We must convert the theta, or the angle that we get, that this formula gives us, to degrees. So when we use this formula, it's going to give us an answer in radians. Then we have to figure out what it is in degrees if the question asks to figure it out in degrees. Okay, so you always have to make sure you keep that in mind. So I've taken the liberty to set up the equation, plug in the numbers that I know. So I'm going to solve for theta. I'm going to divide both sides by 0.5. And then I get theta is equal to 3. Now this is in radians. Okay, so this is theta is 3 radians. The question asks for it in degrees. So now we need to convert 3 radians to degrees. So we're going to use what we did on the previous page. Well, we want degrees, so I'm going to keep degrees on the top, write my ratio, and multiply it by 3. So that's my theta. There's my equation. And solve. So 3 times 180 is 540 over pi degrees. And theta ends up being 171.89 degrees. So this is what my final answer should be. Okay, that's it. Short one, folks. Try some of these questions relating to converting radians to degrees and degrees to radians. Thanks for coming out.